What is the distance in which a car with a rubber tire will skid to a stop on a dry concrete road if its brakes are locked when it is moving at 50 meters per second? So supposing this is our rubber tire and this is our dry concrete road. So the brakes are hit when it is moving at 50 meters per second, and we are looking for the distance that it has traveled during that time. So let's make an FBD first. Let's identify the forces now acting on the tire. So if the tires were moving towards the right, then the direction of the net force is directed towards the right, no? But the car was able to brake because of a frictional force Fk, which is directed towards the left. And there are no other forces involved here, which means that this net force is equal to, so diba, there is no net force, there is no force applied towards the right, that's zero. So the net force is zero minus the frictional force K. But this net force is M times the acceleration of the tire. That's equal to negative Fk, which is mu K Fn. So for the vertical forces, well, the weight here, Fw, since the surface is just horizontal, is equal to Fn. So Ma equals negative mu K, but Fn is Fw. But that weight is mg. So we can cancel out m. And so the acceleration of the tire that time is negative. Our mu K is 0.8 from the table times 9.81 meters per second squared. So it is negative because it is decelerating. It's, the brakes were hit. So 9.81 times 0.8, that is negative 7.848 meters per second squared. So after solving, we were able to get the acceleration. We were to find, the problem here is to find the distance. If we are now given the acceleration, which is negative 7.848 meters per second squared, it was running at a velocity of 50 meters per second, and eventually it will stop 0 meters per second. So what is the distance traveled x? So Vf squared minus Vi squared is equal to 2ax. So x is equal to Vf squared minus Vi squared over 2a. And the final acceleration is 0. So this is negative 50 meters per second quantity squared divided by twice of negative 7.848 meters per second squared. So the distance traveled by a car before coming into a stop is 50 squared over 2 times 7.848, which is 159.2 2762 meters.